Bismillahirrahmanirrahim. Today we will be starting with the uh, properties of the water, chemistry of the water, and during learning this chemistry of water, we will be focusing on properties of the water. We will be discussing different properties, and in the next lecture, we will be looking at the application of these properties. So look at this one. Uh, this is the chemical structure for water. This is the chemical structure for water, H2O, consisting of two hydrogen atoms and one oxygen atom. The hydrogen atom that is comparatively smaller as compared to the oxygen uh, atom. Oxygen atoms. So what is the properties of that? These hydrogen are having the partial positive charge, and the oxygen atom that have the partial negative charge. So hydrogen, oxygen and hydrogen that are held together by the covalent forces. These are the sharing of the electron through the covalent forces. And another thing to remember that these water structure that is not in a straight line, that is on a certain angle. In case of the carbon dioxide, this structure that is on a straight line. It's a straight type of the structure. But in case of the water, that is not a straight type of the structure, and that is affecting most of the properties of the water. Water has the unique properties due to its inclined bondings. So these are held together by the covalent bonding that are strong enough. These covalent bonding that is giving the strength to the water molecule. So water molecule is made up of two hydrogen atoms and one oxygen atom. These three atoms are not in a straight line, they are bent, so there is a net polarization. So this bending in the presence of the partial negative and partial positive charge, that is giving a water molecule a net polarization. And that is a very important for giving the water so many properties, especially the solubility property that is affected by the net polarization. As you know that the water is a very good solvent that is dissolved in much of the things. So the net polarization is responsible for that property. So look at this one. There is two smaller hydrogen atom having the positive charge, and there is a bigger oxygen having the negative charge, so responsible for the net polarization. So that was the structure for the single water molecule. This is a single water molecule, bigger oxygen and smaller hydrogen. Smaller hydrogen have the positive, bigger oxygen has the negative charge. The question arises how different water molecules held together. Here we are talking about the covalent sharing, covalent forces that held together the water molecule. But the question arises how different water molecule, these are the different water molecules that are held together. So here the hydrogen forces that is responsible. These you can see these are the hydrogen forces. These are the hydrogen forces. So these hydrogen forces that held together different water molecules. These are the hydrogen forces. So these held together by the hydrogen forces, and again these are the strong forces, not an easy way to remove those forces, to remove the water molecules. So look at this one. This is the water molecule, and this is the hydrogen forces. This hydrogen bond is actually built between oxygen and of the one water molecule and hydrogen of another water molecule. This is the oxygen of one water molecule and hydrogen of other water molecule. So that held together by the hydrogen bonding, and that is strong enough to hold the water molecules. So look at this one, how that this animation, how that are binding with hydrogen forces. So uneven distribution of the electrical charges that attracts other water molecule to the each other. So look at this one. These hydrogen bonding that is giving specific properties. These are giving specific properties. These hydrogen bonds give water its specific properties. So we will be talking about other characteristics as well as other properties as well. We will be talking about the surface tension, Kappa reaction, ice is less denser than the water, high heat of vaporization, high specific heat, water is a good solvent. So starting with the properties, adhesion and the cohesion properties, you come across with two phenomena. Water is actually attracted by other water molecules, as well as there is an attraction forces with the material. The water is, for example, the water is put in a glass. There, the glass and the water molecule has the attraction force, and the water in it that also have some of the attraction forces. So water is attracted to the other water molecule, that is called as cohesion property, and water is also attracted by to other material. This is called as adhesion property. So oxygen and of the water, you know, water that is the positive charge. Hydrogen of one water molecule attracted to the oxygen from other water molecule, and these attractive forces what gives water its cohesive and adhesive properties. And another property is the surface tension. You may observe that it's difficult to insert on the surface of the water something that on the surface of the water. So because the water molecules are held together by the hydrogen forces, and these are the very strong forces that require some of the additional force to enter the things from the surface. So the that actually turns as the surface tension, as we know previously described that the cohesion of water molecule at the surface of a body of the water that's hold together, strongly hold together. So to overcome that force, you require extra force. And this is the most important property. Ice is less denser than the water. What is the behavior of the liquid? Most of the liquid that contract when they are getting cold. Water has the unique property. Water follow the same rules that it contracts when it is getting cooler, but it contracts up to the 4 degrees centigrade. Below the 4 degrees centigrade, it try to expand. It try to expand until it becomes solid at 0 degrees centigrade. So solid water is less dense. You know that density is mass per unit volume. Density is equal to mass per unit volume. So volume and density, it's an inverse relation. So when the water is cooled down, it get smaller, smaller as the other liquid. So volume is lesser, but below 4 degrees centigrade, that try to expand, the volume is increasing. And when it becomes freezing, frozen at 0 degrees centigrade, that become the ice. So that has no expand too much. So it's will have larger volume and lesser density, lesser density. So solid water is less dense than the liquid water. And how this behavior that can be explained. So you can see due to the hydrogen forces that these hydrogen forces these are responsible to come apart. For other liquid, the molecules, liquid molecule that contract come closer to each other, come closer to each other. But in water, that expands, goes apart from each other. So this creates this void space that is responsible for increased volume. As we told you, and we discussed that below 4 degrees centigrade, there is an increase in volume that is this increased in volume that is decreasing the density. So these void spaces that is responsible for the increased volume, this increased volume. So that is responsible for ice is less dense than the water. It has so many applications. Water molecules in the ice are spaced relatively far apart because of the hydrogen bonding we can see here. And because this is the application, because ice is less dense than the water, lakes do not freeze solid. So when the temperature goes down, there is a formation in the lakes, the ice, and due to less density behavior, the ice comes on the upper side because that is lighter. That comes on the upper side. So the below water, the ice is spread on the upper side, and the water below that remains a liquid that is then much denser as compared to the ice. So the things, living things, plants, animals, fishes, that remain alive in the liquid water during the winter seasons. Another property of the water is the high heat of vaporization. Besides having a slow evaporation rate, the boiling point is very high. Again, the hydrogen forces that is responsible for that is not easily broken down, hydrogen bonds. This is necessary because life exists when water is in its liquid state. Water should be in the liquid state on the earth. It should not be evaporated when the temperature is increased. So that is only possible when the high heat of vaporization of some substance. So many water bonds, what is the concept of that vaporization? Many water bonds that must be broken for water to evaporate. Another property is the specific heat, absorb or the release amount of the large amount of the heat energy with little temperature change. And what is the concept of high specific heat? Basically, this is the type of the energy, heat energy that is visible on the temperature scale, thermometer scale. Temperature is the measurement of how fast molecules are moving because of the large number of hydrogen bonds. A lot of energy is needed to break these bonds. Water heats up slowly and holds the heat longer. As against to that, if we look at the behavior of the desert where the sand is present, deserts are cold at night and hot by the day because no water is available to stabilize the temperature. This is due to the specific heat. And one of the important property is that water is a very good solvent that dissolve much of the things in it. There, this behavior, there are so many explanation for this behavior. The bent structure. This is not the in a specific line. This is the bent structure. Partial positive and partial negative behavior that is also contributing towards the good solvent properties. So look at this one, sodium chloride. Sodium has a positive charge, chloride has a negative charge. So this negative charge that is attracted towards the hydrogen, this positive sodium that is attracted toward the oxygen. So look at this one, this is the crystal for the sodium chloride. Chloride have the negative, sodium has the much smaller but have the positive charge. And this is the water molecule. This is the water molecule that surrounds these ions. So look at this one on the positive side of the water that attracts the negative charges. And the negative ends of oxygen, negative ends that attract the positive sodium. So water is a good solver because it surrounds the ion, have the capacity to surround the ion. So that's all for today. In the next lecture, we will be talking about on the more application side of uh, water. So we will be closing our lecture today here, and inshallah we will be meet in next lecture. Take care of yourself and your